Okay, so just a short video on answering this question. Why should we simplify surds? Now remember a surd, I just highlight this. A surd is the root of a number which isn't going to give a nice answer. And by a nice answer, we mean a ratio answer, a rational answer. So root 40, if you did it on your calculator, it would give this long, never-ending decimal with no repeating patterns. I mean, unlike something like, let's say, root 4, right? Root 4 equals 2. And also root 1/4 equals a half, all right? So these roots here, I'll get my highlighter on, these square roots here give me a nice answer. So these guys aren't surds. And we call these radicals because they've got a root sign, but a radical could give a nice number like this, and a radical could give a nasty number like this. But the definition of a surd are these guys that don't give a nice answer. And by a nice answer, we mean a ratio answer, a rational answer. Okay, so that's tidied up the actual definition of a surd. You might think, well, what's the point in simplifying? And one of the ways we can simplify is by using the rule that actually, if I break down root 40 into 4 times 10, there's a nice little rule of surds that means we can distribute the square root above the two numbers that have been multiplied, and that allows us to simplify to 2 root 10. So what we're saying is that root 40 has a slightly different form, and we can write the form as 2 root 10. Now, if you repeat the same for root 90, you get to some understanding of actually why, why should we simplify surds? It could just be a fun maths exercise. So this is the square root of 9 times 10. Notice I could have chosen 45 times 2, but the goal here is to choose a nice square number. And you can see the benefit of choosing a nice square number, because when we square root each of the individual numbers, then this becomes 3 times by root 10. And now I suppose, in this context, we can see why we might simplify surds, because if the question was actually to add these two together, root 40 plus root 90, instead of thinking, well, how the heck do we do root 40 plus root 90 that looks so different, we can now replace root 40 with 2 root 10. So now we can just write that root 40, a different form for it, is actually 2 lots of root 10. And instead of root 90, a different form to write root 90 is 3 lots of root 10. And so now you can actually think about your rules of algebra, really, that this is 2 of something, and this is 3 more of the same thing. So this is 2 plus 3, that's actually 5 of that thing. So 2 root 10 plus 3 root 10 is equal to 5 root 10. Okay, so there's one reason why we might like to simplify surds, and the reason is that it might make it easier to then do something with those particular numbers rather than leave them in their current form. So if the question was add together root 40 and root 90, you'd be pretty hard to do it as they exist like this. But if you change the format to 2 root 10 and 3 root 10 here, then it becomes a lot easier because you're kind of adding together the same type of surd. So 2 root 3 plus 2 root 10, plus 3 root 10 is equal to 5 root 10.